Hello everyone, we will now see our next tutorial, that is import from text. So in this tutorial we will see how one can use the import from text functionality and can set up their load step attribute having lot of loads. Again, this functionality is also useful for some other attributes like defining your connector elasticity, defining your simulation physics related to your equation attribute. But we will mainly focus on the force attribute in this tutorial. So let's see how one can use this import from text functionality and can set up different load step attribute with different load values. So let's begin. In this tutorial we will be using this bracket assembly. So you can see here this green color one is my bracket and this red color one is my bolted connection, and we will be applying a load at the center of this bolted connection. So we have this bracket with class as solid, this bolt with a class as no mesh because we don't want mesh for that part. We will be having our 1D element there, and this yellow color part, it represents our loading part. So we have done the tagging like this, that is scomp is our load underscore comp, and we have added a s class of load for this loading part. So this is our model for this tutorial, and what we are looking for is we want to apply a load at the center of this bracket. So we will be applying the load in the two steps, so load step 1 and the load step 2. So load step 1 will have their respective loading, that is some forces in x, y and z direction. Similarly, load step 2 will have their corresponding loading, that is different loads in the x, y and z direction. So let's see how one can do this with the help of import from text functionality. You can see here I have opened the bracket assembly in Creo. So this green color part is our bracket, and we want to apply a load at the center here, which is represented by yellow part. So you can see here this load part is the part which is added to specify our loading location. So this part is having load underscore comp as scomp, that is simulation component, and we have added load class for this loading part. Also we have added the other tags as per the requirement, and with this we are done with the CAD model. Now before switching to abstract model file, one need to create a XML file as shown here. So one can give any naming here. So I have just given service load data.xml for this file, and this XML file will include all the details related to your load cases. So you can see here I have specified two load steps, load step 1 and load step 2, and each load step has their corresponding details related to load. So in the load step 1 I have specified the component which is going to be representing my loading location. So that component name I have given load underscore comp. So you must be remembering that in the CAD model we added a simulation component for the part which is representing our loading location. So that simulation component name one need to give here. After that we need to give more details about the load magnitude. So you can see here I want 30,000 Newton in the x direction, 6,000 Newton in the y direction, and in the z direction I don't want any load is to be applied. So that information I have specified here. Again, one can use any string values to represent that. So I have just used fx, fy, fz to represent my loading in x, y and z direction. But one can use any parameter name as per the requirement. So this is specific to load step 1. Similar details I have provided here for load step 2. So you can see here I have specified the component name first. After that I have specified the details about my load magnitude. So likewise one can keep on creating any number of load steps as per the requirement. Also, one can keep on adding the component name as per their loading details. So for example, your model contains 10 locations where you want to apply different loads, then you have to create the 10 component names in the XML file, and you have to fill the corresponding loading details there. So this way one need to create a XML file in order to use the import from text functionality. Let's now see how one can use this XML file in abstract model file. You can see here I have opened the abstract model file, and in the problem definition tab you can see there are some force attributes. So I'll just open one of the force attribute here. So all of you know that what we generally give is like we directly enter the load magnitude in the force attribute. For example, if you want to apply some 30,000 Newton load in the x direction, then I'll just type 30,000 here. In the y direction maybe 6,000, and if I don't want any load in the z direction, then I'll just put 0. So this is the usual way where one is manually adding these values. But now we will see how to use the input from text functionality to define these load magnitudes. So I'll just remove this data. So here just type P and one expression will get popped up. Just click on that expression. Maybe I'll just expand this. So this expression is saying that we are going to use a XML file here to fetch the load data against this component. So for that we need to give here XML file name. So in our case the name of the file is service loads data.xml. Again, you can give any file name here based on the file which you created. After that it is asking for the text parameter name, so I will just type here fx because I want to fetch the value against this parameter from the XML value, and in case if I don't find that value, then what should be my default value? So I'll just put here 1000. So with this expression what we are saying is we are telling that we want to fetch the values from this XML file, and that value should be fetched against this parameter name, and in case the value is not found in the XML file, then use this my default value. So likewise one can give the loading details for other two components also. Maybe I'll just copy paste this data for other two components. I'll just change the parameter name here. Instead of fx I'll just put fy. Similarly here I'll just put fz. So this way we are actually using our import from text functionality in the force attribute. So once done with this, I'll just click on apply and close. Similarly for the second attribute, that is for load step 2, again I'll put the similar details. So I'll just copy paste my expression here. Same for my component 2 and 3 I'll do. Maybe I'll just put here fy. Here I'll put fz as my parameter name. So this way one can specify the force attribute with the help of import from text or the param from text functionality. So once done with this, I'll just click on apply and close, and we are done with setting up our force attribute. Now we will see what happens to these attributes when we create simulation model. Now to create simulation model, I'll just click on this icon. Then it will ask me for the CAD model file, which is to be linked with my abstract model file. So I'll just select this bracket assembly and I'll click on open. So this will create my simulation model. Yes, so you can see here my simulation model is now ready. Let's now see what happens to the point force attribute in the model tab. So if I go here in the model tab and if I expand my point force attribute, let's say I'm opening this first attribute. So you can see here against these three components, values are fetched automatically from the XML file. So you must be remembering that we had used an expression that is param from text, and software has automatically fetched the values against this load case 1. Similarly, if I click on another attribute that is for subcase 2, you can see a respective component 1, 2 and 3 values, those are fetched from the XML file. So this way one can use the import from text functionality. Now what is the use of this functionality as compared to directly putting these load values in the point force attribute? So let's say that you have 10 loading location and you have two load cases or the two sub cases. So if you want to manually enter the values, then you'll have to create maybe 10 attribute for load case 1 and 10 attribute for load case 2. So that will increase your work. Secondly, tomorrow, let's say if your load magnitudes, if they are changing or if they have changed, then again you'll have to update all those attributes manually. So instead of that, if you use this import from text functionality, then you will just create one XML file. There you will give your load step detail, that is load step 1 and load step 2, and inside that you will just specify your 10 loading component and you will just input your loading magnitude against those 10 components. So that one XML file with the help of two attributes is sufficient to carry out that simulation. Again, tomorrow if your loading value change, then you can just update your XML file and you don't have to update your abstract model file even in that case. So that is the use of import from text functionality. Again, we have one more functionality called as import from CAD, but again that functionality has some limitation. For example, for those 10 loading location, you will have to add the different tags, and that will increase your tagging work. So considering this import from XML or import from text functionality, it helps the user when you have lot of loading location and when you have lot of load cases. So with this, I hope you have understood the importance of this functionality. And if you have any queries or any question, then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. Now we will meet in the next tutorial. Till then, have a good day. Bye.